Now that our player can run and jump forever, we should give them a reason to do so. Dinosaurs love eating bugs, so we'll give our player a bunch to collect. Let's create a brand new scene. For the root node, we'll choose Other Node and choose an Area 2D node. This is a node that can be used for 2D collision detection, perfect for something our player should be able to run through and pick up. Once you've created it, rename the node to Collectible. Now, save the scene as collectible.tscn inside the scenes folder. You'll notice the familiar yellow triangle. Just as we have before, let's first add the animated sprite for the collectible bug. Add an animated sprite 2D child node, and in the inspector, expand the animation section. Give it a new SpriteFrames resource, and then click on the resource to open the SpriteFrames panel. Rename the default animation to idle, and change the speed to 12 FPS. Next, click the Add Frames from Sprite Sheet button, choose the collectible idle.png file from the Assets Sprite folder, and in the Select Frames panel, set horizontal to 9 and vertical to 1. Select all the frames and hit Add 9 frames. Add a new animation and call it Collected. Repeat the process, setting the speed to 12 FPS and adding frames from the collectible Collected sprite sheet, again setting horizontal to 9 and vertical to 1. In the inspector now, set the animation to idle and set playing to on by checking the box. Now we can see our little collectible bug hovering up and down. We can go ahead and add our collision shape 2D node. Setting the shape to a new rectangle shape 2D and setting the size to 120 pixels on the X and 90 on the Y. We should also make sure we configure the physics mask correctly. We only want this collectible to collide with our player, so click on the collectible node, expand the collision section, and for mask, uncheck layer 1 and check layer 2, which is our player layer. You can confirm this by hovering your mouse over the number 2. With our collectible scene set up, let's add the script that will let our player collect it. Right-click on the collectible node and attach a script. Call it collectible.gd, and again, make sure it's in the scripts folder. Remember to change the template to the node default one. Let's define a value for how many points we'll reward the player when they collect this collectible. We're also going to get a reference to our world node so that we can call a function on it that will actually add to the score. Since our game script lives on the root world node, we'll use the $syntax and give it a path of /root/world. We'll also get a reference to the animated sprite node so that we can play the collected animation when the player collides with it. Remember, we don't need to use a full path to the node here, since the animated sprite 2D node is a child of the collectible. With our references set up, the first thing we need to do is identify when the player has actually collided with the collectible. For this, we'll need to connect to the body entered signal of the Area 2D node. You may remember from earlier that signals are effectively Godot's version of events. Nodes can fire them when certain things happen, and other scripts can listen out for these events and react accordingly. Inside the ready function, let's connect to our own body entered signal by calling self.bodyentered.connect. Self is a keyword that references the current node. We'll give it the name of the function to connect the signal to. We haven't created this function yet, but let's call it onBodyEntered. Now we need to define this function. It will be passed a body argument, which will be the node that actually collided with this object. The first thing we'll do is check to see if the body we collided with was the player by checking if the body is in the player group. We do this by calling the isInGroup function and passing it the name of the group. In this case, it's player. There's a slight problem though. We haven't actually added our player to the group called player. Let's quickly open up the player scene, click on the root player node, and in the inspector switch to the node tab, and click on groups. Here, let's add the player to a group called player, all lowercase. In the scene panel now, you'll see a small square icon with a dot inside appear next to the player node. This indicates that this node is now part of a group. Hovering over it tells us that it is indeed inside the player group. Let's head back to the script viewport and back to our collectible script. After our check to see if the object we collided with is actually the player, let's call an addScore function on the game node and pass it the value variable we defined earlier. This function doesn't currently exist, but that's okay, we'll add it soon. We'll also do a couple of other things here. We'll play the sprite's collected animation, and we'll also connect to the sprite's animation finish signal so that we can destroy this object when the animation finishes. Let's define the onAnimationFinish function, and inside we'll call the queue_free function. This function queues the node for deletion at the end of the current frame. That's all the code we need inside our collectible script. Next, let's define the addScore function inside our game script. Click on the game.gd script, and first, let's add a score variable and give it an initial value of 0. Next, let's create the addScore function. It'll have one argument, which is the value, to add to the score. We'll simply increase the value of the score variable by the value passed to the function, and then print out the new score to the output panel using the print function. As a side note, you may have noticed that we haven't prefixed this function with an underscore. This is deliberate. A common convention in Godot is to prefix functions that should be private with an underscore. In contrast, a function that is public and can be called by other nodes should omit the underscore prefix. Since we're calling this function from our collectible script, we won't add an underscore prefix. There's a few last things we want to do for our collectible, but first, let's make sure it's working and the score is increasing. Open up the main scene, switch to the 2D viewport, and let's drag an instance of our collectible into the scene. You'll notice that it's a bit big, but we can worry about that later. For now, we just want to test that when our player runs into it, the animation plays, it disappears, and we see a score print out to the output panel. One thing we'll also need to do is come over to the scene panel and drag the collectible instance onto the moving node to make it a child. This will make sure it moves along with the platforms. With that done, hit play, and we should see the player eat the bug and a score appear in the output panel. Which we do. Awesome. Let's add a sound for when the player collects the bug. In the main scene, add a new node 2D as a child of the world node, and call it sounds. Add an audio stream player as a child node, and call it collect sound. In the inspector for this node, drag in the collect sound. Let's go to the script viewport, and inside our game script, we'll grab a reference to this sound node. Just like we did for the player jump sound, we'll add a variable to control the pitch, called Collectible Pitch, with an initial value of 1.0. We're also going to add a variable to specify when we want to reset the pitch of a collectible sound. This is so that we can continue to increase the pitch of the sound every time the player collects a bug. But after a period of not collecting anything, we can reset the pitch. This gives the player some nice positive feedback for collecting bugs. Inside our game's process function, we'll do a similar check as we do for spawning a new platform. Only this time, we'll be checking the value of the reset collectible pitch time, and if it's passed, then we'll reset the collectible pitch value to 1.0. Let's head up to the top of the script and define an exported variable for how long in milliseconds we should wait before resetting the pitch of the collectible sound when the player hasn't collected anything. We'll give it an initial value of 2000, which is 2 seconds. Now, inside our addScore function, let's set the pitch of the collect sound and play it. We'll then increase its pitch by 0.1, and set the reset collectible pitch time variable to the current time in milliseconds plus the collectible pitch reset interval. Now, go back to the 2D viewport and let's copy and paste it a few times and press play to test out our new collectible sound. Looks like it's working. Nice. Next, let's add a score counter to the screen. To add a score counter to our game, let's start by adding a canvas layer node as a child of the world node and renaming it to HUD. By adding a canvas layer as the root of our UI, we can ensure that our UI elements will always appear above the rest of the sprites in our game. This can be controlled by the layer property. By default, it's set to 1. Let's be certain that our UI appears on top of everything else by setting this to 99. Under our HUD node, let's add a child node of type control and rename it to UI. This is the base node for UI elements and has properties for configuring the layout and size, amongst other things. In order to see the UI that we're building, we're going to need to zoom out from our game screen and scroll over to the right a little. The rectangle you can see here is the UI outline. With the UI node selected, locate the Anchors button at the top of the viewport. Click it and you'll be presented with a bunch of options for specifying where the anchor points of this UI element should be. At the very bottom, there is a full rect option. This will ensure that the element stretches to take up the full width and height of our game's screen. This will work great to serve as a root container for our other UI elements. Next, add a new child node underneath our UI node. This time, we'll add a label node and call it score. Click the Anchors button again, and this time choose top right. Next, in the inspector, give it an initial text that looks realistic so we can get a feel for how it might look. We'll give it a text value of score 1000. We'll also change the horizontal alignment to right. Expand the layout section and then the transform section and set the position to 1745 on the X and 10 on the Y to give it some space from the edge of the screen. With the label positioned, let's give it a black outline so that it stands out a bit better against the game's background. Expand the Theme Overrides section, and under the Color section, check the Font Outline box. Then, under the Constants section, check the Outline Size option and set the value to 7. We'll also expand the Font Sizes section, check the box and change the value to 30 pixels. Let's save the scene and go back to our game script. We'll get a reference to our score label, just like we have with our other nodes. Inside our process function, let's set the text of the score label to the player's current score. We can do this by using string formatting. We'll use the %s placeholder to specify where we want the score value to be added to the string, and then we'll use the % operator followed by our score variable. While we're here, let's remove the print call from our addScore function, as we no longer need it. Now, run the game, and we can see that the score counter goes up as we collect bugs. Nice work! Before we continue, let's open our main scene in the 2D viewport and remove the collectibles we manually added to the scene. These won't be necessary anymore, because next we're going to create a few platform variations that have the collectibles on them. Now that we have something our player can collect, we need a way to spawn those items in the world. One way to do this would be to write some code to procedurally place collectibles in the world, but an easier way is to extend our platform spawning system by creating multiple variations of our platform that we can pick at random each time we spawn a new one. To start, let's right-click on our platform scene and choose Duplicate. Let's give it a name of platform_collectible_single. Double-click on this new scene to open it in the viewport. We now have a copy of our platform scene that we can modify without changing the original. Let's go ahead and drag an instance of our collectible scene into the viewport. As you can probably tell, it looks a bit too big. Let's fix that by selecting it in the scene panel and changing its transform scale to 0.3 for both the X and Y axis. Much better. Now it looks much more like a little dragonfly our dino would like to eat. Feel free to position the collectible wherever you like. I'll move it near the centre of the platform. Save the scene, and now open up the script viewport and go to the game script. At the top, where we have a reference to our original platform scene, let's add a new variable that references our new platform. With our new reference added, let's scroll down to our spawn next platform function and make a small change. Instead of directly instantiating our original platform scene, we want to randomly pick one of our platform scenes. At the top of this function, let's create an array to define what platforms we have available. Next, we'll randomly choose an item from this array using the randi_range function of our RNG object to choose a random number between 0 and the size of our array -1. This will give us an index number that we can use to grab a platform from our array. Now let's instantiate the randomly chosen platform instead. If we click the play button now, we can see that we will randomly get either our normal platform or one that has a collectible on it. Before we move on, let's quickly create a couple more platforms. First, let's create one that has a whole row of collectibles. Right-click on our new platform scene in the File System panel and choose Duplicate. Let's call this one platform_collectible_row. Open this scene and let's duplicate our collectible a few times and position them in a row. It's worth noting that you can duplicate nodes using Ctrl-D if you're on Windows. Great! Head over to the script viewport and let's add a reference to this new platform. We can copy our previous line and just change the name. Don't forget to add this variable to our array below. Click play again, and you should now see all three of your platforms appear randomly. We'll add one more just for good measure. This time, we'll make a little rainbow of collectibles. Duplicate our collectible row platform, and call it Platforms Collectibles Rainbow. We'll just reposition the collectibles a little. Save the scene, and again, let's create a reference and add it to the array. Perfect.